Okay, now let's talk about one of the interesting properties of the gold nanoparticles, but before that we have to introduce the surface plasma resonance. Well, it's pretty simple. The Au element, the gold element, the electron in the valence orbital is vibrating by a certain frequency. Now, if we shine the nanoparticles with an incident light, when this electron is in the resonance mode, some of the properties of this material will change, and it will absorb some part of the incident light. As a result of this adsorption, due to this resonance, the color of the nanoparticles will change. Just notice that this is not the re-emission of the another wave. It's not the fluorescence. In fluorescence we had the fluorophore and the light, one wave coming and another wave being re-emitted, but this is not happening here. Okay, all that is happening in the SPR, the surface plasma resonance, is the adsorption of light. Okay, for example, why do you see the black objects being black? Because they absorb some wavelengths, and the one that you see, the one that is reflected, is only the black one, and you see some other objects as blue because they receive the incident light, and only the specific wavelength that they emit is the color that you see. Okay, the surface plasma resonance property that we introduced in the previous lecture is different for the gold nanoparticles with different sizes. Okay, for the small gold nanoparticles, this SPR effect causes these nanoparticles to absorb the light within the blue and green portion, and as a matter of fact you will see the red light. As the size of the gold nanoparticles increases, you will see that the color will shift towards blue, and this is because the SPR effect is changing. So based on size, the wavelength that is absorbed by the gold nanoparticles is changing. Okay, but let's see how we can use this property for detection of the for example, the protein clusters. Here's the simple idea. If we have a suspension of small gold nanoparticles, we will see that they absorb the wavelengths, and what you can see is the red suspension. Okay, now if we introduce a protein into this sample, okay, and if the gold nanoparticles are loaded with some let's say targeting ligands which have the affinity toward this protein, we will have the clusters of the gold nanoparticles around the proteins. Okay, now because of the formation of this cluster, the color of the suspension that you see is no longer red, the color is blue. Okay, so this can be used for the detection of the of the nanoparticles clusters. So by measuring the intensity of the red color becoming blue color, blue, you will somehow have an understanding of how much nanoparticle clusters have been formed around the proteins.